Hi, I'm Dan Litster. Today I'm joined by Michael Yungman, Ethan Halpern, and Scott Neville. And now, let's talk textiles. Welcome everyone to Talking Textiles. I'm Dan Litster of Keyston Bros, a member of ATA and PAMA. The goal of this podcast is to get to know the wide variety of positions and markets that make the advanced textile world turn. We will be talking to professionals in different roles throughout the series to help inspire the next generation of textile professionals and anyone interested in learning more about others' journey in the world of textiles. ATA offers advanced textiles content throughout the year, including the upcoming Advanced Textiles Expo in 2026, taking place November 3rd through 5th in Orlando, Florida. Connect there with industry professionals and discover the latest innovations that will drive your business forward. Visit textiles.org/events to learn more. Our featured guest is Michael Yungman of Yungman Engineering, also Ethan Halpern, American Awning and Blind Company, and Scott Neville, Welhener, HB Wall Awning, and Kansas City Tent and Awning. Welcome to the podcast. So I just want to, since I've given you guys a quick introduction, I'd like each of you, and maybe we'll start with Michael, just to give us a quick high-level bio on who you are, what you do, and a little background.
Yeah, perfect. Good morning, guys. Thanks for having me. So my company, Yungman Engineering, we specialize in signs, shade structures, awnings, tents, things like that. Anything that provides shade, that's what we do. I work with a variety of different companies, mostly in the Southwest, California, Washington, I think it's 7 states we're licensed in, Texas. That's it for me.
Ethan?
Sure. My name's Ethan Halpern. I'm the owner and president of American Awning and Blind Company. We are a designer, manufacturer, installer of custom awnings and metal canopies here in Southern California, and we work throughout the state of California as well as some of the other Western states.
Okay, thanks. And Scott?
Greetings. My name is Scott Neville. I am an owner of Lake Country Investments. We are a Missouri partnership. We own and operate awning companies currently in 2 different markets in Missouri. We have a facility in Kansas City and then another one in the Springfield area. I've been doing this for about 19 years now. Love the challenges that architecture and engineering bring to the table when we're trying to solve somebody's shade, shelter, or branding problem involving awnings, canopies, so forth. We're turnkey. We sell both fabric and metal structures to anybody that'll buy them.
That's perfect. That's perfect. Well, since our topic is large frame structures and working with engineers, I'm a firm believer that engineers are people too, and so we're gonna circle back here just a little bit to Michael, because Michael, I think the audience would be interested in hearing a little bit about your professional journey. You know, how and why you became an engineer, kind of a little bit of that requirements of licensing in terms of your education, qualifications, certifications, all that kind of stuff. And then when you get finished, give us a little primer on what is the importance and the significance of that all-powerful stamp that goes onto the drawings.
Yeah, I guess the journey starts with building Legos as a kid, and
Nice.
that's how it starts. And then, every engineer typically goes through a bachelor's of science of engineering of some sort. And after that, you take a test, which is an engineering training test, which I took in my final year of college. And once that test is passed, there's sort of a 4 or 5 year interim period where you're in training and you just have to go out and learn. So there's no stamp at this point. You're still under the supervision of other licensed engineers. And at that point, if you've done your job correctly, you can sit for the professional engineer exam. So in California, there's 3 exams. We get earthquakes, so each state has its own requirements. So the first state I was licensed in was in California. It's quite a difficult state to get a license in. So if you meet an engineer that's licensed in California, chances are they're licensed in other states too, because California is one of the most difficult. And the whole process between college and getting that licensure was a decade for me. That journey comes with a lot of responsibility. There's a reason why it takes so long to become an engineer. It's because our primary job is to protect society. And I think we do a pretty good job. We're kind of unspoken heroes, I think, because you go to work, you cross over a bridge, you don't think, is this bridge going to fall? You go up in an elevator in a tall building, you don't think, is this building going to tip over? There's a lot of things that don't go wrong. And when they do go wrong, you go, whoa, who did this? Because it's a big deal if something goes wrong in our infrastructure. But behind the scenes, there's thousands and thousands of engineers, and our sole responsibility is to protect society. So I think that's the importance of this job, is to make sure whatever comes across my desk, I think it through and go, okay, what happens when a gust of wind comes, and is it going to blow this off and hurt somebody? Our ultimate goal is to protect everyone in society. So we don't really have to think when we walk down the street. Everything just, we take it for granted. If you go to other countries, they don't really have this complex licensure process or building codes, and you'll see things go wrong quite often. So I think it's an important in the United States, and to really understand how lucky we are.
Wow, great answer. Thank you, Michael, for that. That background is very, very, very informative, and I think that transitions well into our overall topic of doing these large structures and working in engineers. So let's talk first just about some of these big patio designs. I know that's something that's very common for most of our awning member base, where they're doing a lot of these pretty large patio designs, particularly they want them to be clear span. They don't want any obstructions in the floor space area. So
Yeah.
there's gonna be lots of trusses, lots of open area. They don't want posts coming down in the middle where a table ought to be. So I think that really gets into your whole topic of the life safety concerns. So here's the question, and this is a question to the group. What are those critical design considerations and structural parameters that are required to achieve these large clear span patio covers? What are some of the types of systems or interior supporting structures that you get into, such as trussed rafters and I-beams and things like that?
Could I take that question a step further?
Sure, please.
Specifically, how would we go about starting the pricing structure on, let's say, a large patio cover and the customer does not want posts in the middle? Do we have to use a generic truss type layout to price out the amount of metal and welds that we're going to do? Or what's a good place to start for us, rather than saying you're going to have posts every 10 feet throughout the interior? Because that's always, a problem that we have is I can visualize what it's supposed to look like, but until an engineer gets a hold of it and says yay or nay on that design, I really don't know what kind of pricing I can give the customer, what to expect.
Yeah, and Ethan and I work a lot together, Ethan at American Awning. So our experience with this, and we're still learning this process, because if let's say we're doing a patio cover on a restaurant, and it's easy for me to say, oh, we just need a post right in the middle here. Well, that's the view. We don't want that post there. Or, that's where we want to put a table. Or Ethan spoke to his customer, which is the owner, and I didn't. So it's easy for me to just go, okay, this works for me, and do that, and my job's done easy. But when we come across these problems, Ethan, and correct me if I'm wrong, but I encourage you to just shoot me a quick email and go, hey, we're thinking about this design. Here's a quick sketch. I didn't spend all day on this. What do you think? And I'll look at it and I'll go, okay, I got a couple of questions. I'm not going to spend all day on this either, but let's give it 5 minutes. And we look at things that we've done in the past as examples and we say, oh, remember we did one kind of like this a year ago. Let's dig that up real quick. And within 10 or 15 minutes of our time, I think we've gotten pretty close to the mark, right?
Yeah, I think so. I think in general, it's one of the nice things about establishing a relationship with an engineer that you can work with again and again is having that ability to call them, email them, hey, what do you think about this? What do you think about that? But yeah, Scott, I find with us, I wish this was a completely black and white situation where I could always know if they want X, we do Y, and then it works out. But I find that it tends to be a kind of a conversation we have to try to narrow in and get closer and closer on what that'll look like. There's one in particular I can think of right now that I've been emailing Michael about last couple of weeks. I'm trying to zero in on to figure out an unusual design for a project. And so, yeah, I think what's been working for us, I feel like, is maybe I throw something out, we iterate a bit on it, we talk about it, Michael gives me some feedback. I come back at it maybe with a slightly revised design. And so we try to sort of whittle it down, get a little bit closer through each iteration. But yeah, I've been finding that's been helpful. But I guess to kind of circle back to this idea of kind of clear spans too, like what, Michael, do you feel like if somebody brings something to you and they're trying to hit, let's say 20-foot spans in either direction, what are some of those parameters that you're thinking about from your point of view in terms of how to make that work? Is it a matter of member sizes? Is it a matter of having to truss it out? Is it column sizes? Where are you able to kind of push and pull things in order to create what you need, the strength that you need? Is it?
Yeah, you just got to spend more money on material.
Okay.
And that's the easy answer, right? Is okay, 10 feet is quite common with our patio covers. We go, okay, we do that all the time. Okay, you want to go 20? Well, your beam sizes are probably going to need to be double or more. So when you're talking to your your owner and they're suggesting that they want this big open look, give me that information. And in my mind, I'm going, oh, I could solve that problem for you. You're spending more money on beams. So that's a message that you should give to the owner and go, yeah, we could do that. I got an engineer. He could solve that. It's more money. And then they go, oh, we don't want to spend more money though. And that's where we always have a problem is I want to spend the same amount of money, but I want no beams and no posts. And it's like, well, we can solve one of those problems, but we can't solve both of them. So that's kind of where I experience the most problems is when you go back to your customer, I say, hey, instead of a 4x4, we're using a 4x8 square or rectangular tube. Oh, those are expensive. Well, yeah, a lot more expensive. It's bigger. It's more steel. Do you want this look or not? So that's the simple answer, right?
Sure. Michael, is there a certain level of communication you're willing to give your customers before you're on the clock with them and charging them per hour or whatever? Is it basically relationship based, or if I were to call you and pick your brain about some stuff, at what point do you think you'd be like, okay, now I'm using my business in this. Now I'm being an engineer. I'm not helping you get started.
Yeah, we can certainly. I can do the conversation for free. We're not attorneys, right? Well, at least my company. I don't go, oh, the phone. Okay, that's 5 minutes, and we send you a bill of whatever it is. I have a short list of trusted people that I work with, and I've worked with some for a decade, right? So I value my customers, and I can certainly spend a little time with them on a project that they haven't even gotten the bid for yet. I understand that there's a process there, and they may or may not get that job. I don't know if other engineers work like that, but I think the good ones do. I think if you value your customers and you want that next job to come your way, and a lot of them don't. A lot of them, we waste an hour and we go through this process, and then what happened to that project? Ah, it went nowhere. Okay, we lost an hour. Big deal. But we got 10 other jobs. So let's look at those, right? So if you find an engineer that's not willing to have a conversation until you're ready to pay them, I don't know if that's the best relationship for you with that engineer. I think most engineers would have a little conversation for you without sending invoices, right? I think that's
You
pretty
know,
standard, but I can't speak for other companies.
and Michael, that kind of having listened to you and the back and forth between you and Ethan, clearly you guys have got a very productive ongoing relationship. But not every awning shop out there has got a close personal relationship with an engineer to work with. So sometimes they're working with people they really haven't, especially if it's an out-of-state engineer, had the opportunity to work with before.
Yeah.
So I guess a question is, how much preliminary design work and information does an engineer want to see before they begin their analysis? How much detail and drawings does the awning shop need to kind of come up with to present to you so that you can begin work?
Yeah. Yeah. Good question. I mean, in a perfect world, I like all the work to be done and presented to me on a silver platter. It's great. I'm very grateful when that happens. And they go, well, we did this really excellent survey and we know exactly what we're attaching to and where to do it. And everything's to the inch on the drawings. That's great. I'd rather that. But sometimes it's more of a concept. So if I get a concept drawing, the best answers I can give to my customer is based on the information that's presented to me. So if I get a really vague, it's 18 or so feet, and maybe we're attaching here and over here, and I don't know, we might do 2 or 3 posts. You're going to get a very, here's kind of what we're dealing with sort of answer from me. I can only give you exact information if you give me exact information, right? So the better information I get, the more I can help. And oftentimes, if we're not sure and we didn't do a proper survey of the area, it ends up costing my customer more money because they come back and they go, oh, you know what? It turns out we can't put a post here. We got to shift it over 4 feet. And okay, well, now I got to redo everything, and everything's changed now. So I got to spend an hour or 2 to redo it, and I send a bill. So I think it's best to get the information up front. I know that sometimes that's hard, but especially with the existing, we're dealing with existing structures, right? And we got to know exactly what we're dealing with, because if we're wrong, later on, you got to come back to me and go, hey, we were wrong, and we got to change it. And now I got to do more work.
Can I jump in there, Dan?
Please.
So, Mike, you brought up a good point, the revision. And this is something that you and I have, of course, have had many conversations about over the years. And I know you can't really give me a blanket statement here for when a revision is required versus saying, yeah, you know what, we're close enough to the original design. You're going to be fine if you have to shift that post over, let's say, 6 inches as opposed to 4 feet. But when you are considering having to revise your calcs, what's going through your mind when you're making that decision to, yep, we got to revise, or no, you're safe making that shift over a few inches? How are you determining that?
Yeah. Well, a lot of times we go, hey, we're just gonna widen our canopy by 2 inches, or right. And I'll do a little work, and you know what? It's so minute. It doesn't change anything. I could see that things have changed, but not enough to really. We don't build usually up till failure point. I leave a little breathing room. So if you do a minor thing, we're fine. But if you're doing an extreme change, or a lot of times we just get bad information on, let's say, a wall. We say, oh, we thought this was a concrete wall. Turns out it just looked like concrete, and it actually was a stucco wall or something, and behind it is framing. Okay, now obviously we've got to redo our attachment points, right? So I just think the survey portion of it is really important. If you guys are out in the field, and rather than send a guy back out to do another investigation, take a lot of photos and send me photos too. The photos are so helpful. But when I get photos, I'm like, great, I can, you guys were there. I wasn't. I can go on Google Earth and I kind of look, but I'm getting a bird's eye view of everything, and I'm going, I can't really see what's going on from a Google Street View. I do my best. But if you can go and take photos and go, here's the concrete we want to attach our post to. And I look at it and I go, that looks terrible. That concrete looks like it's from 1950. It's destroyed. It probably doesn't have any reinforcement in it. I can immediately say, you know what? Stop what you're doing. We're putting footings in or something. I don't know. Every project's got its own challenge. It's hard to make a blanket statement on all of them.
Hey, Michael, could I ask you something else kind of along those lines?
Yeah.
Let's say that we're putting a new patio cover structure on an old building, one that we don't have plans for. We don't have cut sheets on the walls. We don't have anything. We don't know anything about it other than its age. Are you guys, as engineers, going back and reviewing data that you can find with the city or with the county or something to get more info on the attachment walls? Or what's happening behind the scenes there if I'm only responsible for the patio cover and I don't know really anything about the building?
Yeah, I won't be the person to that's a process. Sometimes you got to go in person, and this job is 1,000 miles away, or dig up permits from the 40s or 50s or something. It's going to be very difficult to get the information I need. I'm
Right.
relying on my customer to do a survey and to go there and tell me, I want you to go in person and do the measurements, because we're going to have a hard time with sorting through building plans from the 80s. Even they're
Right.
often they're illegible.
What can you say as far as liability goes? You can engineer your structure that you and I have been talking about, but how it plays with the wall that it's connected to on the old building, what are some things, what kind of risk are we getting into there?
Yeah, in my drawings, I'll identify a scope of work, right? So I will take responsibility for, let's say, this new patio canopy and its attachments to whatever structure. And we'll do our best to investigate what that structure is, identify it on the plans. But at some point I say this is by others, and verify in field via VIF, right? You'll see that we do have 6 inches of concrete to attach to. And then another note saying, if it's not 6 inches of concrete, let me know, call me, and we'll figure out another plan. Don't just attach it because it's 2 inches of concrete and it's not working. Yeah, and then with the building too, I don't want to take responsibility for a building, right? So I'll end my scope of work. What I will do is I will identify, here's the loads we're placing onto this building. If the owner or someone or the city is concerned that this building can't handle the loads that we're attaching to this building, I encourage you, and I have a list of other engineers that would take those loads that I'm from my canopy to the building and say, hey, can you look at this building and determine if this building is okay? Right? We can offer that too. And we can even go a step further. And how far back do you want to go to where you say, okay, we have to identify our scope of work. We have to say clearly this region is what we're working in.
Yeah.
And at some
point, reminder, you're not the only person looking at this. Once the permit's pulled and engineering's done, it's going to a municipality or a city. and they probably have their own people that are going to look at it and concur or whatever, right?
Yeah, and they might suggest that we do something else, right? So we're at the mercy of whatever certain cities that we work with are, we already know that they're going to ask for different requirements. And each city is different. I mean, some cities have snow. A lot of the work that Ethan and I do is in California. We don't have to worry about snow, which is really nice. But then when you get into snow, you have you have an entirely different thing to worry about, right? The weight of that snow, and is your slope on your roof good enough to where that snow can shed off? Is there a roof above it where snow could fall onto your canopy and just destroy it with impact? There's so many other things to think about. So it really depends on where you're working too. And if you're working in a snowy region, usually I think about wind. Everything's wind in California, and sometimes earthquakes. But these structures are light, so earthquakes usually isn't a huge deal. But then we get into snow, and it's like, okay, wind, you sit back for a second. Now we're going to look at snow and wind at the same time. So it depends on where we're working. You said you're in Missouri, right?
Yeah, we have snow.
Yeah, heavy snow.
Yeah.
Yep. And Kansas can have some pretty good steady wind.
Yeah.
And Michael, just to kind of drill down a little bit more into that last question that Scott asked, when he was bringing up, like, you're dealing with an older structure, your scope ends at the connection to that older structure. In a perfect world, if we were to bring another engineer on board to try to satisfy the building side of things, I'm assuming that person would most likely have to go out and do a site survey. Is that correct? To really give us a definitive answer on how well this building could take on the loads of our awning or our canopy?
It's not always necessary, but if it's within driving distance, I would say, why not? Yeah.
But if this was a building that we didn't have any pre-existing plans for, all we had, let's say, were photos and our own survey, is you think that some structural engineers are able to potentially work off of that for some structures?
I would be able to work off of drawings that you would create if you couldn't dig up any information on the building. I think that I know your company, Ethan, is capable of going out and creating drawings for me. So I could work off of that. Some companies don't have the resources to do good drawings. Every company's different. Some companies don't have drafters, and everything is done by hand and sort of a sketch format, which makes things a little bit more difficult. It's nice to have good drafters.
We've been kind of talking about, that patio canopy or large canopy type of structure so far. But I know one of the things that both Ethan and Scott get involved in, and I'm sure you do too, Michael, is some of these shade sail projects where you've got a very, very large shade sail or multiple shade sails connecting to buildings, connecting to poles that have been put into, very large poles and columns that have been sunk into concrete. So I guess a question that I have is, what is the most efficient or effective method for connecting shade sails, particularly to buildings? Because that's something we were just kind of talking about. What is the condition of that building? And when you think about how much stress and is placed on shade sail attachments, really, what is that? What is that best method of connecting to the buildings?
These shade sails, the tension shade sails, are kind of a different animal completely. When we're talking about canopies, I'm not so worried about the building as I am on a shade sail. The canopies, we usually have a rigid frame, and the frame itself is supported in, many different areas, a lot of contact points. With the shade sails, usually we have just a concentrated load in one tiny part of the building. And then 20 feet later, we have another highly concentrated load. And yeah, these are very underestimated loads. Companies that don't really understand the shades say, hey, we're going to put up this shade here. No big deal. We'll put a couple screws here. Oh my God, no. These things develop really high tension loads. We got to really think this through, right? And that does place, like you're saying, a lot of loads on the building. It's definitely something to understand. What are we doing to that building? What's the building framed out of? Be great if it was all concrete, right? But sometimes we get a older building with 2x4 studs. What do? Can you pull 2,000 pounds on that wall? You'd have to reinforce that wall for sure. So yeah, I'm glad you asked that question, because it sounds like we're all familiar that these tension shades can develop really high tension loads.
Yeah. And I think, when when we've got that more freestanding type of a shade sail where it's all attached to 9 or 12 or even larger size steel poles that are that are sunk down into a concrete cage and then oddly installed at an angle, not perpendicular, which always cracks me up. So you're putting a lot. There's a lot of stress even on those poles, which is why they're put in an angled and then kind of stretched or stressed into being straight. But when you put them on the building, I think that's where a lot of people start getting worried, because they don't know if that face brick and the concrete behind it and all of that is up to snuff.
Hey,
Yeah.
Michael, is there a specific training course or continuing education or something that engineers such as yourself have to go through to consider shade sails? Anything like that specialized that Joe Blow architect or engineer down the road wouldn't really be equipped to speculate on or to calculate?
I don't know if we do have continuing education, but I haven't seen. I buy a big package for continuing education credits, and I haven't seen anything on tension shades. It's a very specific thing too. I don't think there's a lot of people out there really doing it. Most engineers.
Was there a class that you took or something that got you introduced into shade sales specifically? You're like, I'm gonna nail these things. I'm gonna be a professional at these.
I worked for a number of different engineering firms. I started out with land development stuff. I thought that was boring. And that's what a lot of civil engineers will do. They'll do land development where you parcel land and build a road and drainage. That's probably the bulk majority of civil engineers. I started working then for another company in 2008 or 2009 that did signs and shade structures, and I thought that was a lot more interesting. So I've developed a lot of experience since then, and then worked pretty much in that area since 2009. And so it's all experience.
Yeah. Interesting.
Yeah.
So are engineers actually able to calculate exactly the loads on those HDPE mesh shade sails, or is that just kind of a approximation?
I mean, it's very theoretical, right? It's hard to compare that a tension shade sail to, let's say, like a beam structure, post and beam structure. It's a lot easier to work with steel and welds and rigid structures. And shades are flexible, they move, they're going to stretch, they're not going to be the same this year. You're going to go out there next year and they might have sagged. And our tension loads are based on sag, so that theoretically changes over time. I mean, these are tricky, right? Which is probably why a lot of engineers don't want to deal with it. It's a lot easier. I'd much rather work with steel than shades. Shades are tough, and what kind of science is there when it comes to installing them the way that we spec out in our calculations? Do you have a special instrument that measures pretension? Probably not. I think they kind of just go, that's good, that looks good to me, right? I've been out there when they do the installation and there's turnbuckles, and I think they just go by feel when installing them. And it doesn't seem to be a very exact science. We can say, hey, we want exactly this amount of sag and this exact shape, but then when the installer goes to install it, how do we know we actually have that? How do we know it hasn't changed in 6 months? It probably will, or a year, or 5 years. All this stuff's changing. It's really tough to get an exact number on it.
Yeah.
What would you tell customers? Would you mention any of that to them, or what would you tell them as far as the engineering is good for this exact day, this exact tension, and if something were to happen 5 years down the road after this thing's seen some weather, we're no longer liable for it because it's not exactly the way it was when we put it up?
Yeah. Well, I think that over time, what's the lifespan of these fabrics? Is maybe
10, 12 years.
10, 12 years.
10 to
right?
12 years, yeah.
And at that point, it's time to reevaluate everything. I also heard from customers, they go out periodically to check on them. Ethan, do you guys go out on a routine every couple of years and say, hey, the shade looks like it might be sagging a little bit more because of weather, and it's been cycled so many times through wind? How often would you say you go out and retension those?
I wish I could say we were out checking on products every year, but to be honest, we're not. And if we do get by job sites, of course, I always like to stop and look and see how something's holding up. But I can't say it's anything that we do on a consistent basis.
Right. Would you wait for the owner to say, hey, it looks like this is time to maybe like touch this up a little bit and tension it?
What that makes me think of, and I just kind of put this out to all three of you, is what are some of those recurring client issues that you're running into that you frequently encounter? They're problematic issues, and this is largely brought about by the client that you're dealing with. And so, like Michael, whether that is the end user for you or the awning contractor that you're dealing with, and for Ethan and Scott, mainly the expectations there of that client, what they're looking for. And these are client issues that recur over and over and over and over again.
I can't speak for anybody else, but I know that budget is always the main concern when it comes to some of these larger structures. And maybe the customer wanted curtains that hung on the end of the patio cover at the get-go, but it was going to be an extra so many thousands of dollars. Or maybe they wanted fans or lights or misters or something hanging from the structure. So I think a good question would be, what kind of communication would we have with the engineer as far as planning for the future like that? Like, I know this guy is going to come into some money in 2 years and he's going to want all this extra weight hung from the interior of this canopy. What do we have to do to make it work now? Now we're revisiting things.
Yeah, maybe incorporate it from the beginning, whether or not, maybe design the end result and then build towards it.
Overkill?
Yeah, I mean, I always encourage, when my customers come to me with a concept, and they're in the bid process, I say, could you bid a little bit more material? Labor is so much money these days. If you're using a 1x2 or 1x3 aluminum, I would imagine your labor is around the same. Could you bid a little bit more on your material end in case we needed to go there? Because an engineer is going to design what we design to is a minimum design criteria. I don't like to design to the minimum. We can design over that. We just can't design under that. So design a little bit more on your material And now you know you're safe if later on your customer says, hey, we want to add some more stuff. And oh, well, great. We kind of overbuilt this a little bit and we can do that now.
Yeah.
It's really hard to go in later and work with something that's like right on the edge of working. And now you want to make it a little bigger later. And you're going, wow, we barely made it last time. And now you want to expand on it. I mean, what would you say your material costs versus your labor costs are? Is material 50-50?
At the time of construction, yeah, I mean, you could say that, well, let's work backwards. Let's say it's 10 years down the road and they want to put a new fabric top on it. Sometimes the replacement is going to be about half the total cost. You could say something around those lines. So I guess that's another segue is the reoccurring thing is going to be, okay, we did this patio cover a decade ago and now it's time for new fabric. So hopefully we engineered it such that we can remove the fabric and put new stuff on without seriously disrupting the building, the restaurant, the operations, and all that stuff, or mess with the engineering.
Yeah.
Michael, one question I had that popped up as you were just talking, when you're talking about minimum design criteria, I've always assumed that engineers, you guys were typically finding that, but then bumping that up another, I don't know how much, 10, 20, 30% to ensure that there's that buffer. Is there a quantitative amount that you try to build above and beyond what that design criteria is? Or is that not how you guys think about it?
As long as we meet that minimum design criteria, we're okay. I don't add on to that if that's what you're asking. I don't say, okay. We're building almost, let me bump it up 20%. If we meet it, great. I trust that I've done my job. And if we don't, we got to change something, right? Rarely would I say, oh, this structure looks good. It meets the minimum design criteria. Let me just add a little bit just for, I don't do that unless I feel like there's maybe an important reason to do that. Like I just don't feel good about it or something.
Gotcha.
If I feel like, hey, this could see an avalanche of snow from another roof and I don't really like that roof above it. I don't know. I just don't feel good about, although it meets this minimum design criteria, I don't trust this other part of it. Maybe I'll reinforce something if my gut tells me to. But I don't just do that on every project.
Okay. One thing that we run into also where, if we're having a conversation, maybe an early conversation about shade sails or about a canopy, and we're talking footing sizes, I can't tell you how often I get the surprised look from a general contractor when we describe what type of footing is going to be required for this canopy. I have my own way of trying to explain to them why the foundation for a canopy or a shade structure has to be larger than that of a building. But I'm just curious if maybe you have kind of an elevator pitch that we could potentially use when we're trying to explain this to somebody who's not an engineer as to why our canopy requires such big footings.
That's because I said so.
Okay, got it. I'm writing that down.
That's right. I love it.
It's funny because like a lot of things aren't considered. And when you talk to other people, they don't consider that wind goes in all directions. They're not considering wind uplift. They're going, there's not a lot of wind. Well, wind goes up too, right? So you build this 20 by 40 foot canopy, maybe there's 20 pounds per square foot of wind on that. What's 20 times 40 times 20? That's how many pounds of uplift you could get on this thing. That's a lot, right? You need really heavy footings. That's one reason. Concrete's heavy. Good. We want that weight. So we need to hold this thing down. Okay. That's one good reason. But another one is maybe there's earthquakes there and this thing is shifting side to side. And we need to keep it from tipping over. We achieve that by going down and getting deep in our soil. We don't really get much out of the first foot or two of soil. I know a lot of people want to do these 2 foot digs on their canopies. 2 feet of soil doesn't really do anything. It doesn't do much for you. The first foot is like ignorable almost. It's just topsoil. The second foot, you're just like, okay, great. You're getting a little something. You got to go down like 4 feet. Usually we go down 4 feet because that's when you achieve, some sort of stability with the soil. So you got to go down. I think we do like 18 square or maybe a 24 inch square, 4 feet deep. That's where we start usually. And if you've done enough canopies, that's kind of our starting point. We're like, let's try that one.
Yeah.
Right.
Now, and
Makes
then
sense.
and then when you go instead to like a spreader footing, let's say like a 48 by 24, how are you able to justify that? I know maybe not for a shade sail, but for a canopy, is it just because it's giving you enough weight?
Yeah, two different designs, right? So sometimes we can't go down. There's a utility or something in the way, another footing. So we can either go wide or we can go deep. Somewhere in the middle, you're not really doing a good job of either one. It's not very efficient. So if I see like, if you took like a 3 foot by 3 foot, 3 foot deep cube footing, I would say that's pretty inefficient because it's neither a spread footing nor are you going deep enough. You're kind of wasting concrete at this point. Let's choose depth, which means you can go narrow, or you can go really wide and do a spread footing. And they both work in different ways. Spread footing is just you're getting the bearing pressure out of the soil by going wide, and or you're going down and you're going deep and narrow. Those are the two best options.
Sounds great. Well, good. Well, listen, hey guys, we're getting towards the end of our time here together, but I'd like to have each of you just give kind of a quick, short answer on just to our awning and structural members that are on this webinar. What kind of advice would you give, Scott and Ethan, about working with engineers and working with some of these large structures to your fellow awning fabricators? And then Michael, kind of that very, very same question. What would you recommend to awning fabricators about working with engineers? So whoever wants to go first, grab on.
I'll jump in here first. I think from our vantage point, I think it's like Michael was saying earlier, it's really about relationships. And I think finding a good engineer that you can establish a good working relationship with is important. So finding somebody that you can bounce ideas off of, that's going to be open, that's going to help you solve problems, I think is really important, as opposed to just finding somebody that is going to stamp your plans, maybe do it as cheap as possible and just be done with it so you can get on to the next project. I think it's way more important to have a good working relationship. So yeah, I'd recommend finding a company, finding a person that you can establish that with.
Ethan is totally correct. And I can tell you from personal experience that we have been through a number of engineers in both of our operating areas. And unfortunately, some of them retire or have health issues or whatever, but I would totally love to have the kind of relationship that Ethan and Michael have, where they can bounce ideas and really get things planned out before you take the major work aspect. Because a lot of our customers, they just want to kind of know a budget here and there before they decide they want to do something. And it can be really hard to figure out some of these. I mean, I can go back and look at old pricing on similar structures, but things change a lot and metal's a lot more. And it would be really cool to have an engineer like Michael that I could bounce ideas off of and make sure I'm just heading in the right direction.
Oh, that I just have to mirror on what you and Ethan said too. Yeah, it's establishing a good relationship and having an understanding of if I need to do something and say, hey, we need to change this, and not getting into a battle of not wanting to do it helps me. Some people are just fight and say, no, we don't want to. Okay, how about, and I give you like three, I try to give my customers like three options. Okay, we got to do one of three things to solve this. And so, option one, no, we don't like that. That costs money. Option two, no, we don't like that. That costs money. Option three, no, we don't like that. That costs money. I don't have any other options for you. These are the options, right? And they all cost money to solve problems. So it's great if, for me, on the working with my customers, if I could get that reciprocation of, yes, okay, we have to do something. I choose option 2. Great. And we move forward. Otherwise, we just go back and forth and back and forth. And I end up I've fired people because they just go, we've been doing this for 2 weeks now. I spend more time working with this project than 15 other people I've already answered to in the meantime. So yeah, that communication, that relationship, all that's really important to me.
Fantastic. Well, I just want to take the opportunity here on behalf of ATA and Pamela to just thank the three of you, Michael, Ethan, and Scott, for your time here today. You guys were great guests. You really kept this conversation flowing easily. You hardly needed a moderator, honestly, with the dialogue back and forth. And that's what makes these types of podcasts really fun and enjoyable, not only to participate in, but to be the member who gets to watch this podcast. So thank you for your time. Thank you for your expertise, and appreciate each of you.
Thanks, Dan.
Thanks, Dan. Thank you, Michael.
Dan.
Take care.
Yeah, I appreciate it, Michael.
Thank you.
Thank you for joining us for this episode of ATA Talking Textiles. ATA is a non-for-profit association representing the international specialty fabrics marketplace. Learn more about the events, workshops, and webinars ATA hosts throughout the year at textiles.org/events.